To prevent circuit from being overloaded and causing fires, they invented things called fuses. And these were the original fuses, where this ribbon here, if it got too hot, would just break, literally. It would snap in two, and it would open the circuit, preventing an overload. Okay. Now, the modern circuit breakers, or excuse me, we don't use fuses in houses anymore. Now we have circuit breakers that there's a device in here. When it gets too hot, it makes the circuit breaker flip and turns off like a light switch. Okay, so then what you're supposed to do is figure out what caused that to do that, and if it was a problem, then you need to repair the problem. Otherwise, you can just flip the circuit breaker back on and complete the circuit. Okay, so let's think about what effect a different circuit would have on the brightnesses of bulbs. Okay, so here we have two circuits in parallel with each other. This has two bulbs that are in series with each other. Okay, so if we think about the current in this circuit and this circuit are going to be the same. Okay, but these two are sharing that amount of current. So these two would be pause. They would be dimmer than this one. So this would be brighter than these two. These two would be the same brightness as each other. So what happens if A goes out? Well, B would go out as well. What about C? If A goes out, B would go out, but C would remain the same brightness. Okay. Now, solve for the overall resistance and the current in the circuit below. Okay, so we have a 5 ohm resistor that's in series with two parallel 30 ohm resistors. Okay. So first we have to solve for these two. 1 over R equals 1 over 30 plus 1 over 30. 1 over R equals 2 over 30. So R equals 30 over 2, which would be 15. 15 plus 2 is, or excuse me, 15 plus 5 is 20. Okay. Then to find the current, current equals V over R. V is 10. R is 20. 10 divided by 20 is 0.5 amps. Okay, let's try another one. Simplify those. Simplify down to 5. 20 plus 5 plus 15 is 40. Okay. Then the current, I equals V over R. V is 10. R is 40. So, all right. Now, let's throw a curveball at you. What if you have two resistors that aren't the same and they're in parallel? So it's a little harder to do, but not that much. You just say 1 over R equals 1 over 15 plus 1 over 12. Uh-oh. You can't simply do this. So there's two ways to do it. You can take 1 over 15, make it a decimal, and then add it to 1 over 12, make it a decimal, and take the inverse of that decimal. And that gives you the equivalent resistance. Or you can do the complex fractions. You can say 1 over R equals 1 over 15 plus 1 over 12. So 1 over R equals, the least common denominator would be 16. This would be 60. This would be 4/60ths. And this would be 5/60ths. So 1 over R equals 9/60ths. So R equals 60/9ths. So 60 divided by 9 is roughly 7. It would be 6.7 or something like that, which would round up to 7. So 10 plus 7 plus 15 is 32. Okay, and then the current would be 10 divided by 32, or 0.31 amps. All right, so that does it for circuits. I think you'll enjoy the circuit lab, the video lab, hopefully.